evapotranspiration. And we're going to hear that term used all the time in the trade. They call it the ET. That's just, people are just going to say ET. We're not talking about that little alien that made millions of dollars in the movies. We're talking about evapotranspiration. And it's the summation of the total evaporation and transpiration that occurs generally on a daily basis. We usually rate these things daily, but we could do it weekly, we could do it monthly, we could do it seasonally. Depends on what we're trying to evaluate. In most cases, we want to know what happens day to day. We're getting sophisticated enough in water scheduling in this day and age that we really want to know what's going on from one day to the next so that we don't over-irrigate or under-irrigate over a very controlled period of time. Now, to add to that, there's one more thing that happens out there, and that's the water that is held by the plant. Okay, and that's not included in evapotranspiration. So we bring in another term called consumptive use. CU, the pretty obvious thing, we call it CU, consumptive use, and we're going to use that term all the time. There is one slight difference between ET and consumptive use. It is this. The ET plus the water held in the plant will equal the CU. The evapotranspiration plus the water held in the plant equals the consumptive use. So now we're including that water that is being held inside of the growing organism. And we know that most plants are going to be over 90% water. So they can hold quite a little bit of water in them. Now, you get a corn plant, it's 12-foot tall corn plant is going to have a lot of water in it. So there is a certain amount of water held in the field that does not get transpirated, does not evaporate, but it's not in the soil either, it's in the plant itself. It's a very small amount. You know, usually somewhere in the 1% range of total water within the whole system that we're dealing with. But it does have to be acknowledged that it does exist, and that is the very difference between consumptive use and evapotranspiration. Just so that you can talk the talk. Now let's look at, for this total consumptive use, and really we really want to know what the consumptive use is, because that is the bottom line. All the factors put together. What are the factors that need to be dealt with? We talked about one, leaf area. Okay, factors that affect this, leaf area is a major player. Another would be the stage of plant growth. You know, we know that corn is going to have a very high consumptive use rate when it gets big. But when we first plant it, you know, it starts out as bare soil. In a few days, we get a little stem about like that. Well, it's pretty obvious the cornfield, where the corn's that tall, its transpiration is going to be pretty negligible. Hard to monitor even. Now, its evaporation is going to be pretty big because there's no ground cover. But we don't have much transpiration. Of course, as it gets bigger and bigger and bigger and bigger, the transpiration increases more and more and more and more. But there is a point in its life where it hits full maturity, and then it starts to go the other way. It starts to decline. And then all of a sudden, you start having a drop in the consumptive use. Once it goes past maturity and starts going toward its final reward, it starts to shut down, and it starts using less and less water. And then at a point it totally dies and it doesn't use any more water.